Hey guys, Dr. Brown here, and just a few moments ago we performed a differentiation on this function. We took the derivative of the natural log of e to the x over 1 plus e to the x, and we ended up with 1 divided by 1 plus e to the x. This video, we're going to integrate that and see if we come up with this, what we started with in the previous video, differentiation. All right, so how are we going to handle this? I'm going to let u equal 1 plus e to the x. It's a good u sub here. All right, so du, derivative of a constant is 0. Derivative of e to the x is e to the x dx. So e to the x times the derivative of x, which is just 1. 1 times e to the x is that. Chain rule, we have to take the derivative of x itself. Okay, so du over e to the x equals dx. All right, now I have a little challenge here. I have an e to the x term. Let's actually, we'll say 1 over u, and dx was du over e to the x. I'm in the u world, or trying to be, so I don't need a term with the x in it. So let's take this. I have u equals 1 plus e to the x. Solve it for e to the x. So u minus 1 equals e to the x. So I can replace this e to the x with u minus 1. Awesome. So now I have two linear terms in the denominator. The tool now, by the way, the tools, u sub, trig sub, integration by parts, partial fractions, power reduction, long division, completing the square, method of quadratics. Okay, we've just used u sub, so we've used this tool. Now partial fractions. This is perfect for partial fractions. All right, the only thing I need here is that term. So I can, with partial fractions, I can say this equals the integral of a over u plus b over u minus 1. And all of these are integrated with respect to u. Okay, now a little bit of algebra here. I have 1 over u minus 1. And I'm saying that equals a over u plus b. Now it's the integral, but I'm leaving that sign off for the moment. Okay, if I multiply both sides by u times u minus 1, u minus 1, u minus 1. Okay, you'll notice in this side, all terms cancel except for the 1. In this one, the u canceled. I'm left with a times u minus 1 plus the u minus 1 cancels plus b u. Okay, I need to solve for a and b. So when I look at this, if I let u equal 0, I'm left with, so u equals 0. So now I have 1 equals a times 0 minus 1 plus b times 0. So this term is gone. So negative a equals 1, so negative 1 equals a. Okay, if I let u equal 1, now I have 1 equals 1 minus 1 is 0, so I have 0 times a times b times 1. B times 1. So 1 equals b. All right, so a equals negative 1, b equals 1. Now I can go back to this. I have to run out of room here. So now I have 1 over, I have the integral of 1 over negative 1, which is a. Heck, let's just put it right here. Negative 1 over u plus 1 over the integral of u minus 1. I'm going to erase this, so take a snapshot. 3, 2, 1. Okay. All right, so the integral of negative 1 over u is minus natural log u plus the integral of 1 over u minus 1 is the natural log of u minus 1. Okay, so what is u? U was 1 plus e to the x. So I have minus the natural log of 1 plus e to the x plus natural log of u was 1 plus e to the x minus 1. So u is 1 plus e to the x minus 1. The 1's cancel. I'm left with just e to the x. So this comes natural log of e to the x. Now again, we have the same, the rule of natural logs. I can rewrite this as natural log of e to the x minus natural log of 1 plus e to the x. And since this is negative sign, I can rewrite the entire thing as natural log of e to the x over 1 plus e to the x. And I think that was what we started with before in the previous video. We'd taken the derivative of it, came up with this, we just integrated that and ended up back with the function we started with before. Okay, study natural logs, several tools we had here, u sub and partial fractions, which we used here. So good tools to have. And there's many rules for partial fractions. These just for the rule for linear terms. There's quadratic terms, repeating quadratics, squared terms, many different rules for that. So study those. All right, that's all for now, and keep studying. We'll talk to you next time. Thanks.